Hello everyone, welcome to another very important session in which we will be discussing some more important questions and very important concepts for our upcoming CSIR NET and the GATE Physics exam. So I hope that the discussion which we have done till now in our previous classes, all that will be clear to all of you. But in case if there is anybody having any doubt anywhere in the discussion we have done till now, you can surely let me know about it and we will try to consider those points then. So initially, before going ahead with the discussion, I'm quickly gonna let you know about the important things, and I want to let you know about the things like which can help you to take your preparation to the very good level. So actually, guys, if you want to do the best preparation under the guidance of top educators and you don't want to miss the important courses and the classes by the top educators, so you can take the Unacademy Plus or Unacademy Iconic subscription. And even guys, if your friends want to take the subscription or want to start the preparation under the guidance of top educators, you can share this information with them too. So all the details about the Plus, Iconic and the Lite subscription have been shown here on the screen. And if you want to get the discount in the total subscription amount, then you can use and apply the code Anjali Live as mentioned here on the screen to get the discount in the total subscription amount. Also, guys, if we are going to talk about the other important things, so in upcoming days, so many new courses by the top educators will be starting on Unacademy, which will be helping you to do the best preparation under the guidance of top educators. And even so many courses are going on right now. So if you will take the subscription now, you will be able to do the best preparation with these courses as well as whatever will be starting in upcoming days, like till the time you are going to take the subscription. Okay, you will be able to join all those courses and the classes for that much duration for which you will take the subscription. So this was something important, and now I'm just quickly going to show you some more slides. Like, this is something about the Unacademy learning app. This is about the session itself, and here we are having some details about me. Here we are having the information about the community feature, which will be helping you to get the latest updates and important information. So guys, this was something related to the important points related to Unacademy learning app and whatever can help you to take your preparation to a very good level. So today we will be taking the questions from the quantum mechanics part, and anywhere if you will be having any doubt, you can surely let me know about it and I will try to consider those points then, okay? So let me just give you the first question. And as you know, we are going to take the questions from different concepts, different points, and we will also be talking about those concepts here in the session. Give me a second. Mm. Okay, guys. So our first question is gonna be this one. So we will try to include the questions from various concepts and the points, which will help you to make a better command on different things and to have the idea like how you will be solving such type of questions. So here is the first one. Suppose Hamiltonian of a conservative system in classical mechanics is H is equal to omega xp, where omega is a constant and x and p are the position and momentum respectively. The corresponding Hamiltonian in quantum mechanics in the coordinate representation is. Options are negative iota h cut omega delta over x delta over delta x plus, okay, not plus, minus 1 over 2. I think I should write it on the next slide, otherwise it will not be clear. Negative iota h cut omega x delta over delta x minus 1 over 2. Second one is negative iota h cut omega x delta over delta x plus 1 over 2. Third one is negative iota h cut omega x delta over delta x. Next one is negative iota h cut omega over 2 x delta over delta x. Try it now. If you will not be getting it, guys, I'll be helping you in that case, like how you should proceed further to solve this question, what are the steps you need to take, and everything we will talk about. So let me know if you're gonna get like, okay, this is what I will be doing, this is how I'll be getting the answer. So you can try that and tell me what is the right answer according to you then. And if you're not gonna get it, so we will be talking about that part, don't worry. Okay, I'll let you know what steps you have to take for any such type of question, but if you are gonna get it, that's great. So suppose Hamiltonian of a conservative system in classical mechanics is h is equal to omega xp. This is in classical mechanics, okay, they have given you. Now where omega is a constant and x and p are position and momentum respectively, the corresponding Hamiltonian in quantum mechanics. So classical expression is given, now quantum mechanical expression we have to consider. In the coordinate representation is what? So here we are going to have h is equal to omega xp. But you know in quantum we deal with the operators. And that means I can't keep just x and p. Like in quantum mechanics when we deal with the operators, xp and px will have two different meaning, right? It's not like just the same meaning. So that means what I will prefer to do, I will multiply with 2 and divide by 2. At the same time, I will write it as xp plus px, right? That's what we will do. Once we are going to do it this way, in that case, what will happen? In this case, we are simply going to consider omega over 2 xp plus px. Now, in this case, we are going to consider just we need something on which we can operate the operators. So let's say I'm going to take psi as the wave function at which we will be operating the operator. So psi I will write here as well. Now what next? The next thing will be h psi is equal to omega over 2 x, then p is what? P is negative iota h square delta over delta x, and psi is a function of x itself. Okay, so you can separately write the psi x with both terms, or you can just write it like together. Like together means psi x to be common, right? It's up to you. Now next is negative iota h square delta over delta x. Again, x is there and psi x will be there, right? Psi x means psi is a function of x. So everywhere you can replace psi with psi x, that's all right. Now next thing, we just have to do the simplification. So we will be getting h psi is equal to omega over 2. This will be just operating on psi. So we are just going to have negative iota h squared x delta psi over delta x, right? And then negative, then this is first term and this is your second term you will have. So what will happen in this case, first term as it is and iota h cut as it is, delta psi over delta x, okay, then plus, is it plus, whether in the product rule we should have plus, but negative sign is there, so I'll be keeping the negative sign, okay. So it's gonna be iota h cut. Now the differentiation of x with respect to x will give us 1, so I'm just gonna have the negative iota h cut sine x, that's it, done. Now next thing, once we have got this part, when we will add the first two terms, we will have negative iota 2 iota h cut x d psi over dx, okay, and then negative iota h cut psi x. So what I will do, I will take the iota h cut common, okay, from both the terms and psi common from both the terms. So when you are going to take it common, you will have negative 2 iota h cut, as well as you will have, sorry, iota h cut will go common. Let me just write it on the other slide. Omega iota h cut over 2. So in the first part, you will just have negative 2 delta psi delta over delta x. And then next one, you will just have negative iota h cut, you send common, so just negative 1. Now if you will take this 2 inside the bracket, so you will get omega iota h cut, it's going to be negative delta over delta s, negative half, negative. If you will take negative sign common, you will find, guys, one more thing. We had the x present here while x was not in the second term, so we didn't note it down. We have to note it down, okay. Now x delta over delta x, when you will take negative sign common, what you will get there, you're just gonna get the, let me just write, negative 1, which is just negative iota h cut x delta over delta x plus 1 over 2. This is what you will have. So negative iota h cut omega, okay, x delta over delta x plus 1 over 2, which is option B, and that is the correct one. So this is how you are just going to get option B to be the correct option for this particular question. Let me know if in case there is anybody having any doubt, we can consider it. But if everything is clear, then that's great. So tell me if there is anything not getting clear to you, we can talk about it. But if everything is getting clear, I'll be giving you the next question then. Okay. Similarly, we will be keep on discussing different concepts based questions, so that you will be able to work on different concepts. You will get to know about the different concepts here. So the next one is the ratio of the energy of the first excited state, that is E1, to that of the ground state E0 to that of a particle in a three-dimensional rectangular box of side L, L, and L by 2 is. Options are 3:2, 2:1, 4:1, and the next one is 4:3. So you can try it now and let me know what will be the right answer according to you. But if you are not gonna get it, I will let you know then. So actually, guys, in this case, what's going to happen? In this case, the ratio of the energy of the first excited state E1 to that of the ground state E0 to that of a particle in a three-dimensional rectangular box. And the side of the box is given to us as L, L, and L by 2. Means Lx, Ly, and Lz is given to us, right? So in this case, we need to find the ratio of energies of first to the ground state energy. So in this case, we will have the E energy is equal to nx square pi square h square over, okay, over 2m lx square, which is equal to L itself, plus ny square pi square h square over 2m ly square, which is also L, okay, and then nz square pi square h square over 2m lz square, which is L over 2, which is L square over 4 then, okay. So it will give you nx square plus ny square plus 4lz square, and then denominator 2ml square you will have, right? In this case, you have to find the ground state. So for ground state, you will take 1 1 1. So when you will take 1 1 1, it will give you 6. So energy for the nx, ny, nz to be 1 1 1 will be what? 6 over 2 ml square, right? And for the first excited state, it will be either 2 1 1 or 1 2 1. So 2 1 1 or 1 2 1. And in that case, what will happen? You are just simply going to consider the 2 1 1. If you will take 2 rows of 4 5 5 and 4 9. So 9 over 2 ml square. If I will take the ratio of ground to the first excited state, I'll get 3, okay, ground to first, right? So you will be getting 2, what is this? Is it first to ground? Okay, yeah, sorry. First excited state to that of ground. So first one will be in the numerator, which means this one should be in the numerator and this one should be in the denominator. So 9 over 6 you will get, which is 3 over 2, and that's your right answer. That's option A. So this is how the statement matters a lot, whether they have asked for the first to ground or ground to first. Okay, that is very much important. Now, once you have got it, we are ready to work on the next question. But if in case there is anybody having any doubt anywhere, just mention it. We will talk about that part. So here is your next question waiting for you. The differential cross-section for scattering by a target is given by d sigma over d omega, which is going to be the function of theta and phi, equal to a square plus b square cos square theta, if n is the flux of the incoming particles particles, then the number of particles is scattered per unit time is. Options are 4n over 3, 4 pi over 3, n a square plus b square, 4 pi n a square plus b square over 6. Next is 4 pi n a square over 2 plus b square over 3. Option D is 4 pi n a square plus b square over 3. Try it now and let me know as you will get it done. What is the right answer according to you? So it's gonna be like from the scattering part. And if you are already familiar with this thing, that what formula you can use in this case, that's great. But if you don't know, I will let you know then that what steps you can take and what will be the best process to solve it. So they have given you the differential cross section, right? And you have to find the number of particles scattered per unit time. So in that case, you have to just find the total. Okay, the differential cross section is given, you just have to find the total. So total cross section will be what? That is sigma. Sigma is going to be what? That is going to be the integration of d sigma over d omega. But for that, you have to integrate for theta and phi both. So how that integration can be done? So it's going to be common constant term a square, then integration 0 to pi for theta, 0 to 2 pi for phi, sine theta d phi. Okay, d sigma over d omega I am taking there, which is this. So a square plus, that's going to be b square 0 to pi. Okay, then we are going to have here cos square theta sine theta d phi. Okay, and for d phi you will apply the limit 0 to 2 pi. So you can even write it like a common limit, like we have just wrote in the previous part. So I can also mention it this way, that is integration 0 to pi 0 to 2 pi, and that's how you can even solve it. That's up to you how you want to consider. So a square times 4 pi, you will have this integration, plus b square times 2 pi for the phi, and then 2 by 3 you will have for the other case. So that's how you got it. And when you will just simplify it, you're finally gonna have 4 pi a square plus b square over 3. Okay, this is the sigma value. But if you want to find the number of particle scattered per unit time, so that will be what? Sigma times n, right? So it will be 4 pi n a square plus b square over 3. This is how you will be able to get it. Tell me if in case there is anybody having any doubt in this part, we can talk about it then. But if it is getting clear, let's go for the next question. If there is any doubt, let me know about that, guys. But if it is clear, then that's great. Very good morning, Pravalika. So our next question is gonna be a Hermitian operator, that is operator O, has two normalized eigenstates. Has two normalized eigenstates. That is 1 and 2 with eigenvalues 1 and 2 respectively. The two states u, which is going to be cos theta, and then 1 plus sine theta, and then 2, and v, which is going to be cos phi 1 plus sine phi 2, are such that VOV is equal to 7 by 4 and UV is equal to 0. Which of the following are possible values of theta and phi we will have. And options are, should I write them here? Let's try, because then we will have everything on one slide. Theta is equal to negative pi by 6. Phi is equal to pi by 3. Theta is equal to pi by 6. Phi is equal to pi by 3. Theta is equal to negative pi by 4. Phi is equal to pi by 4. Theta is equal to pi by 3. Phi is equal to, where the phi we can write? Let's try if we can adjust it. No. Phi is equal to negative pi by 6. So okay guys, we can take the new slide, or we can write it here. Pi by 4 and phi is equal to negative pi by 6. Okay, now you can start working on it and tell me what is the right answer according to you. What do you think is the correct option? A Hermitian operator O has two normalized eigenstates, 1 and 2, with eigenvalues 1 and 2 respectively. The two states U, which is U and V, are such that V O V and U V, how you can consider their Dirac notation, that's what has been shown here. Other than this, they have considered that which of the following are possible values of theta and phi. That's what you have to find, right? So in this case, what we have to do, we just simply need to follow the given conditions, like here, this one, and the other one, this one. So when you will follow the given conditions, you will simply be able to get the theta and phi by just following these two conditions. So VOV, O is the operator. When you are operating it on first, that is one state like this, it gives you the eigenvalue 1. And when you operate it on 2, it gives you the eigenvalue 2. So in this situation, what will happen? In this situation, it's simply going to give you the cos phi plus 2 sin phi. And then with V, its Dirac notation will give you cos square phi plus 2 sin square phi, that is 7/4. If somebody is having any confusion, please tell me. I can explain that to you then. And now next thing is, you're simply gonna take the cos square phi plus sin square phi, that will be equal to 1, and plus sin square phi as it is, because 2 sin square phi you had. Then you are just gonna have this value equal to 1, okay, as per the identity. So this will give you 7/4 minus 1, which is simply going to be 3/4. And when you will remove this square from here, it will give you sin phi is equal to √3/2. And when you are going to consider it, the phi is equal to sine inverse square root 3/2. Okay, so now this is going to be value at what? 60 degree. So you will say 60 means what? Pi by 3. So you got the phi is equal to pi by 3. Okay. And now if you will look at the options, the phi is equal to pi by 3, where you had in option A, in option B as well. So two options are having the same value. That means you have to work on the second condition to check out the theta value as well. And when you will consider this condition, what you will get? Let's see. U in the bra vector, V in the cat vector. When you will solve this Dirac notation, you are going to get cos theta cos phi plus sin theta sin phi, which is cos theta minus phi, is equal to what? 0. So cos theta minus phi is equal to 0. You know it will be 0 at the plus minus 90 degrees, which is plus minus pi by 2. Phi is already, you know, is pi by 3. So you will just enter it here. Plus pi by 2 and minus pi by 2 you will have here. When you will just shift this value on the other side, it will give you pi by 6. And it will give you, when you are taking plus pi by 3 on the other side, so the first thing will give you 5 pi by 6, and the second one will give you plus pi by 3. Is it gonna be negative? Do we have 5 pi by 6? No. So in this case, if you will just take the other value there, you are gonna get the negative pi by 6. Look at this, minus pi by 2 plus pi by 3. Then you will take the LCM, it will give you negative pi by 6. So you got either this or this. So only negative pi by 6 is given to you in option A, and that's your right answer, because the phi value is also matching with the option A, which is pi by 3, and the theta value is also matching with the option A, which is negative pi by 6. If you are having any doubt in doing the calculation, you can tell me. We can go over that part, but if it is clear, that's great. And now we will be taking the next question. So you can see, guys, if you're going to focus on the question statement and you are getting like, okay, this is given, and you follow that part like step by step, then surely you will be able to get the answer, okay? You will not have difficulty in working for any particular question or solving it, getting its answer. It will be easy for you. Let me just give you the next question now. Okay, guys, you can start working on this one and let me know what do you think will be the right answer according to you for this question. If you will not be able to get it, I'll be helping you in that case. So the question is, consider the two lowest normalized energy eigenfunctions, psi naught x and psi 1x, of a one-dimensional system. They satisfy psi naught x is equal to psi naught star x and psi 1x is equal to alpha d psi naught over dx, where alpha is a real constant. The expectation value of the momentum operator in the state psi 1 is what? So basically, they have given you psi naught by defining it this way, first of all. Then they have given you psi 1, and that's a function of psi naught itself, as you can see. So when you know this, in that situation, what will happen? In this case, you are just going to consider that since psi naught is equal to psi naught star, right? That means it is equal to its complex conjugate, and that shows it's real. When it is real, the psi 1, which is dependent on alpha and psi naught, so that will also be real because alpha is a real constant and psi naught is already real. So we know that the expectation value of momentum corresponding to any real wave function will be what? It will be 0. Expectation value of momentum corresponding to any real wave function or the bound state wave function will be 0. Hence your option B will be the correct one, and this is how you're just simply gonna get it. Tell me if in case there is anybody who's gonna have any doubt. So this is a kind of trick which can anywhere work, while even if somebody will be finding it step by step with the normal average or the expectation value formula, they will also get the same answer, but that may take more and more time. So just to save your time and to get more answers, okay, to solve more number of questions, you can directly use the trick wherever possible. So like here, we are just gonna directly use the trick then. Tell me if there is any doubt, otherwise I'm gonna give you the next question, guys. Okay, next question is here. Try it now, and if you don't know how to do it, I'm gonna tell you the trick or the steps to work on this part. So actually this is going to be from the perturbation part. When you read the question, guys, you can easily get to know from which topic we are having this question. So as you're reading it, you can see it's clearly mentioned it's from the perturbation part, right? So in this case, what will happen? The shift in the energy of the ground state you have to find. So in that case, you just have to consider the average value or the expectation value of the perturbation applied to the system. If it is a variable perturbation, variable perturbation means what? It means like it depends on x, y, z, theta, phi, anything like that. So whatever is changing, like it depends on that value. So in that case, if anytime you want to find the first order correction to the ground state energy, then you just have to get the average value of the perturbation applied to the system. So here in this case, what's going to happen? In this case also, you just have to get the average value of the perturbation applied. And when you will get the average or the expectation value of cos square phi, it's simply 1 over 2. Even for cos phi, the expectation or the average value is 1 over 2. For cos square phi as well, it is 1 over 2. So when you will find its average or expectation value, you will get a over 2r square, because a over r square is a constant and its average value is 1 over 2. So you got a over 2r squared. That's your option C, which is the correct one. So the trick is, whenever the perturbation applied to the system is a variable perturbation, means it somewhere depends on x, y, z, or theta or phi. So in that case, your um, first order correction to the ground state energy will be equal to what? The average value or the expectation value of the perturbation applied to the system. And this is how you're just going to consider 1 over 2 for cos square phi, and a over r square will be remaining as it is. That's how you're just going to get it. Tell me if in case there is anybody still having any doubt, we can talk about it then. But if it is clear, that's great. We are gonna have our next question here then. Okay guys, let's take the next one. The product delta x delta p of uncertainties in the position and momentum of a simple harmonic oscillator of mass m and angular frequency omega in the ground state which is going to be 0 is h squared over 2. The value of the product which is delta x and delta p in the state which is e to the power negative iota p l over h squared and 0, where L is a constant and P is the momentum operator is. Now options are h squared over 2 root m omega L square over h squared again. Okay, yep, it's same. Option B says h squared only. Option C is h squared over 2. Option D is h squared over m omega. H squared square over m omega L square. Try it now. Let me know if you are gonna get the answer, but if you will not get it, I will help you in that case. Like, to know about the right steps you have to follow to get the answer for this question, or what can be done. So we will be talking about that part as well, but let me know if you can get the right answer and you know the process. So here are some of the facts which are involved in this question's answer, some of the points which you already know, then they can help you. And if no, you don't know, I'll let you know today. So first thing is, the question is related to expectation values somewhere, because uncertainty, when we find, we use the expectation values of those operators, okay? Or the values you are gonna consider there, like position and momentum in this case. Now in this situation, what will happen? The system, that is even important. So the system is what? Harmonic oscillator, okay? That's important. The value of the product delta x delta p in the state e to the power negative pl over h squared and 0 is what? So in this situation, the product delta x delta p of uncertainties in the position and momentum of a simple harmonic oscillator of mass m and angular frequency omega in the ground state. Okay, so basically first thing you need to know is the expectation value of position and momentum corresponding to any nth state in case of harmonic oscillator is 0. That means when I will write the uncertainty in x, which is just square root expectation value of x square minus expectation value of x and its square. So this value is 0 because expectation value of x is what? That's going to be 0 corresponding to any nth state, right? So in this case, what will happen? You are just simply going to consider expectation value of x square. Now, in this situation, if we are gonna talk about the next thing, that's going to be when you are going to consider the momentum case. Same way, it will also give you just this much. Why? Because expectation value of momentum corresponding to any nth state for a harmonic oscillator is also 0, but not momentum squares expectation value. Okay, so its second term is again 0. Now in this case, when we talk about the expectation value, it will be the wave function, okay, and then x square, then wave function again. And here you will have wave function p square and then wave function again. It is the bra vector, it is the cat vector, okay. So when you will see the new state, which is this one, in the bra vector, it will be remaining what? The complex conjugate you will have to take, means the power will become positive for iota term, but in this case it will remain same. So in one situation the power is positive for same term, in second one it's negative. So when you will multiply both the terms, you will get e to the power 0, which is 1, and remaining you will just have the 0 state. So that means it's same as the previous case. So when that value you had, okay, in that situation you have considered for this particular state the product of uncertainties was what? H cut over 2. So in the second case also it should remain same. Why? Because the values have not been changed, they are remaining same, okay. And how they're remaining same, that's what we have just observed. So that's how your option C will be the correct one, because the product of uncertainties we will have same as what we had earlier. So H cut over 2 is our right answer in this case. Tell me if in case there is still any doubt anybody's gonna have, guys, we can talk about it. But if everything is clear, then that's great. I'll be giving you the next question. Try it now and let me know as you will get it done. If you will have any doubt, I'll be explaining it soon. So actually, guys, in this case, what's going to happen? They're talking about orthonormal. It's very important for everyone to understand what we mean by orthonormal. So orthonormal is having the three different terms in it. Like not three exactly, but just two. But the third one itself is orthonormal, right? So orthonormal. When we say orthonormal, we are talking about orthogonality condition and normalization condition. Orthogonality condition means the two different wave functions when you will take, and you are going to take their Dirac notation, it is 0. And for normalization, it's the same wave function, and its Dirac notation will be giving you 1. For the other case, it's giving you 1. So in this situation, what's going to happen? The psi with phi, it will give you 0. Okay, means two different wave functions. So if I'm going to keep it, the first one in the bra vector, it will change to the row matrix. And AB will be what? It will be 0. For psi, it will be a square is equal to 1, which will give you a is equal to plus minus 1. For this one, it will give you b square plus c square is equal to 1, right? But you can see when a is non-zero, which is a is having plus minus 1 value, so b must be 0 to have this product 0. So that is only in option C. And C then will be plus minus 1. It's satisfying here as well. So your right answer is option C for this particular question. Tell me if in case there is anybody having any doubt, we can talk about it then. But if everybody is getting it, that's great. So this is just the simple thing like you have to do. You have to check out the orthogonality condition and normalization condition, and then finally we are just gonna get the A, B and C possible values. Tell me still if there is anybody having any doubt, we can consider it then. But if everything is clear, that's great, great, great. One more question. The energy levels for a particle of mass m in the potential, that's going to be Vx is equal to alpha mod x. Determined in the WKB approximation. Square root 2m integration a to b square root e minus vx dx is equal to n plus half h squared omega. It's h squared pi, not omega for this case. Let's write pi here. Okay, next thing. Where A, B are the turning points. And n is equal to 0, 1, 2 and so on to R. Option A is En is equal to h squared pi alpha over 4 root m n plus half to the power 2 by 3. Option B is 3h squared pi alpha. Okay, instead of h squared, I'm just gonna take h in the options over 4 root 2m n plus half to the power 2 by 3. Option C is 3h squared pi, still not h squared, just h. Okay guys, even the powers will be quite let me just write all the expressions. Here we are having in the first one 3 by 2. Here we are having 2 by 3. Now let me just write this one. 3h pi alpha over 4 root 2m n plus half and its power 5 over 2. Option D is h good, h pi alpha over 4 root 2m n plus half to the power 2 by 3. This is what we are going to have. I will let you know that what needs to be done in this case and how you will be able to get the answer. So guys, in this case they have given you the potential, which is Vx is equal to alpha mod x, right? And now since you know that how the V depends on the x to the power 1, right? And you want to find like how the energy will be dependent on n. So you need to know, as per the WKB approximation method, the En will be proportional to n to the power 2 nu over nu plus 2. So what is this nu here? That is the power of x, which is 1. So 2 ones are 2, 2 over 3. That's what we will have the exact dependency on n. And if you will see, out of the given options, only one option is having the 2 by 3 there, and that's option B. And that is your right answer then. So this dependency, if you know, it says V proportional to x to the power nu, then En will be proportional to n to the power 2 nu over nu plus 2. So in our case, we had the V is equal to alpha mod x, and then E will be proportional to n to the power, its nu is 1 here, so 2 over 3. Okay, so that's how option B will be the correct option. This is how you have to do it. Now let me know if in case there is any doubt anybody is gonna have. We can consider it, and if everything is clear, then that's great. Done. So we will be keeping it this much right now today in this session, guys, and I hope each and everything is clear to every one of you. But in case still there will be any doubt anybody will have, you can surely let me know about it. So this is going to be a slide regarding the iconic subscription. Even now the important notes are available on the learning app, which will be helping you a lot to take your preparation to the next level. Also guys, in upcoming days, many new courses by the top educators will be starting on Unacademy. So if you don't want to miss them, you can take the subscription and you can start doing the preparation under the guidance of top educators with the well structured and well planned courses by the top educators. And even guys, whatever courses are going on, whatever sessions you missed, like, you will be able to check out the recordings for them as well. And whatever courses are going on, you will be able to check out, or you will be able to join and attend all the sessions of those courses as well. And along with that, whatever courses will be starting soon, you will be able to join all those courses too, which will be helping you a lot to take your preparation to the next level. So this slide is regarding the iconic subscription. This slide is regarding the plus subscription. All the details have been shown here. This is about the light subscription, and all the details about the plus iconic and the light subscription have been shown here on this slide too. So guys, depending on which subscription you find more beneficial for yourself, you can take that one, and you can easily compare the plus iconic and the light subscription on this slide, and you can get to know which one you think will be working better for you. Okay, and you can take that subscription then. So guys, we will be keeping it this much right now in this session. If in case you will have any doubt anywhere, you can surely tell me about it. In upcoming days, many new courses by the top educators will be starting on Unacademy. So if you don't want to miss it, you can take your subscription and use and apply the code Anjali Live as mentioned here on the screen to get the discount in the total subscription amount. Even if you will be sharing this information with any of your friends who want to take the subscription, you can let them know about the code too. That's Anjali Live, as mentioned here on the screen, and they will be able to get the discount as well by using and by applying the code. So let's keep it this much right now, guys. And thank you so much, everyone, for joining this session. If there will be any doubt, you can surely let me know about it. Okay, let's keep it this much. Thank you, everyone. Bye. Take care.